Good morning, everyone. Reminder, your final project is due, in your case, December the 2nd. So please, hopefully you are working with your team or you're working alone. Both options are fine. Use, remember, due date, December the 2nd, use before our final exam. For today, our last topic, databases. Next week, my goal is to do a full review to help you for the final exam. In your case, our session is Thanksgiving. So what I am going to do for you is to share the video with the review that I do in the previous section. So if you have some time next week and you watch the video, not next week, during the weekend, or just before the exam, it could be helpful. I am going to share that with you. We do not have a live meeting. For today, our last topic, databases. What I am going to do today is a 1 hour review of what some of you are going to review or are reviewing in another class, in the database classes. I am talking about CSI 412 and or 414. Some of you, this is a review of 1 hour of something that you know because you are taking the class or you are going to take the class, and this is a summary of what you are going to cover there. But for others, not computer science or software engineers, this is a full introduction of the last item in software developing. Usually, when you create an application, when you create a piece of software, sometimes, most of the time maybe, that application handles data. And the data, the storage of the data, do not happen in the software that you develop. The storage of the data, the handling of the data, is the responsibility of another application, another piece of software. And as a short name, we're going to call that the database. Several different options. I am going to show you some of them. Yeah, it's the last Zoom meeting. Next week, Thanksgiving. Next week, your exam. Check the calendar on campus. Okay, so software. We review architectural models. We talk about this application for desktop, for web. And it doesn't matter if we're talking about a desktop application, model view controller, if you remember the pattern. In some point in the elements, we put the database, we put the handling of the data. We talk about layered architecture, and there was this last layer for the data or for the database. We talk about client server applications, the web, the mobile, whatever. And there is always the possibility of having a database in the server side. Most of the time in the server side, just like when you access MyASU, just like when you are working with your mobile, usually the server have highest computing characteristics. So you can put things there and just accessing your client, whatever information is there, with all the handling and the responsibilities of the storage there. It doesn't matter really. What you do in your software is something that I can summarize like this. You have your classes, your methods, whatever is the functionality that you are solving, and one of those methods, one of those classes is going to have instructions to connect to another system that we call the database, that is the one that is going to deal with storing and giving you the access to retrieve the information. How do you do that? A couple of lines like this. I do not want you to be expert in these lines. The only thing that I want to do is to point out items that you need to know. Number one, usually when you connect your software with a database, you need something like a driver. The same key idea that happened when you connect a piece of hardware. You need this software that is going to handle the low-level situation. Usually, you do not work doing that one. You use that one. You get that one from some place. In the same way that you download the drivers for your printer. You get this. You load this. You include this in your program. And then you have access to the things like a connection. And I want you to notice, what do we use for connection? The database is a resource in the same way that any web page is a resource for your browser. When you want to connect to a database to a system that is handling the data, the only thing that you need is, well, the IP address for that resource, in which computer that resource is living. Could be your own computer, the local host, or could be anything else in the world. You can be running your software here, and the database is in another place, another computer in another part of the world. You only need the IP address. You can access the database using internet. And obviously, in that place, in that computer, in that system, you can have more than one database, and each database have a particular name. In my example, I have this database system running in my computer, localhost. In my example, my database is ASU, is the name. Therefore, the address is, well, the protocol, Java database connector with a particular database. MySQL, I am going to talk about the providers, is the brand of one of them, localhost, and the name. That is a resource. And I am going to connect my program, this program in Java, with that resource. And once I am connected, the next thing that I can do is to talk with that resource. Talking is like, I can ask that system, the database, I need a new place to store data. Database, I need you to give me, for the student with the ID 3, the full name. I need you all the classes that this student with this particular ID is taking, the grades. It's a conversation between the system that you develop and the database. And if we're talking about a particular conversation, we need to talk about a language for asking for data, a language for asking to store, update, or delete data, a language that is going to look something like this, a language that is called SQL. If you work with databases, a particular kind of databases that I am going to explain this, but for a particular group of databases, you can work with them, with those systems, using this language SQL. And you're going to listen a lot about this. So I have my program in Java or in C, C++, whatever. And somehow this language is going to have libraries, APIs, or something that help me to connect with a database system. And once I have the connection, I can send SQL instructions and I'm going to get answers. Instruction, answer. And in that way, my software can get advantage of a database system. Something that I did not program, something that I just get, download, install, and can use. Depending on what you are doing here, the variable, this one, yeah, is this one, SQL instruction. Thank you. Is the string that contains the instruction. Yeah, good catch. This is what you do. Now, you're going to notice the importance of knowing the language. The language is like knowing another programming language. It's like knowing HTML when you want to develop web applications. It's not because you're going to use HTML to develop the application, but at the end, HTML is going to be involved, or CSS. With databases, with handling data, somehow SQL is going to be involved, well, for particular type of databases that I am going to mention that. So your software, your connection, a new language, handling the data. Moving forward, there are two categories of databases, generally speaking. You're going to have databases that use SQL, and therefore, sometimes, in some references, they are called SQL databases. But the real name, the correct name, should be relational databases. Databases that follow the relational model. We're going to talk about it, relational model, relational databases, those that apply SQL language. And we have the others, the ones that are no SQL databases. SQL and the others. For the others are the object-oriented databases, document-oriented databases, key-value databases, graph-based databases, a lot of them. We're going to focus here for only one reason. The database model that you use to store and retrieve structured data like your grades, the information in the university, the information in a bank account, anything that is related with transactions is relational, is data connected with data. I am going to show you this. The other one, these ones, are getting popularity. Why? Because these ones are the ones that you use to store data that have no structure, like a lot of documents, a lot of pictures. And you have a bunch of pictures. There is no structure between them. And you need to know which pictures have a cat or a dog. You have a bunch of documents and you need to know if there is any relationship between those documents. You have information about one person, like in social network, what you like, what you post, what you do. There is no connection. It's just information. We want to store that. We want maybe to connect them, figure out how they are connected, the graph model. And in some point, the goal here is moving to machine learning, moving to inferences, moving to figure out models that represent the population that is handling or creating those data. Very good ones, getting popularity still. If you have data, structured data, the bank, the university, and all those old school things are going to be relational. I am going to talk about relational a little bit more. So, relational. Let me be clear. A relational database or a SQL database is the following. A bunch of tables like Excel spreadsheets, something with columns and rows. And every single column represents one attribute of something. Like if you think about the student, you can think about this big spreadsheet in which you have a column, last name, maybe your ASU ID, your email that is unique also, all those columns. And you can think about the rows like every single one of you. Every row is a record, every column is an attribute, and you create this table like in Excel, but in a big scale. And the database system is the one that is going to handle that. It's going to be management, do the management of that. You have one table for students, such as student, your ID, your name, and in the row, my ID, that number that they give you when you register, your name, your email. And then another table for the classes that are available in ASU. And for those classes, you are also going to have a table, and the table is going to have also an ID, also maybe a name for the class, something else like a description. So the class number 1, or if you want the 101, a unique number, a description, whatever. And more. And then what happened when you enroll in a class? What happened in the database? There is another table. Another table that is going to have the information of your enrollment. Your enrollment, you can think about another Excel sheet that is going to have only this number that represents the student. All the other information is in the other table. And this number, the ID from the course. And when you enroll one class or two classes, the information inside of the computer looks like this, like 3 different spreadsheets in Excel. But you do not need to care about this. The database system is the one that is going to take care of this. What you are going to do is to use the language SQL for the relational model to ask the computer, to ask the database system, hey, I want you to store information about this new student, John Doe. And maybe the computer automatically assign a new ID, the next one. Or you know what? I want you to enroll John Doe in CSE360. And the computer needs to translate John Doe for a particular ID and CSE360 for another ID. And those two data is the one that we're going to put in the table enrollment. A system with a bunch of tables taking care of the relationships and taking care of the best way to handle the data to take care about the performance. That's it, the relational model. Any database that works in a different way, any database that is not using tables, attributes, records, and this kind of relationships that are going to have a fancy name, I am going to talk about it. Any database with a different approach, a different philosophy, is usually called a NoSQL database and could be in any of the categories that I mentioned before, non-structured data. So SQL, non-SQL. SQL, relational model. Relational model, used like that. Tables, attributes, records, rows, columns in the table. Microsoft Access, yes, is one of the SQL databases. It's one of those in which what you do is to create tables and attributes that are going to become the columns, and you can create the relationships. Yes, Excel is one of the examples, one of the first commercial databases for personal use with this model. Good. Okay. Moving forward, it's like, good. Okay, relational model. If you think about your software and all the options that you have for databases, I want to be clear. You have several options, but when you go to the option SQL databases or relational databases, I am pretty sure that most of you, if you have been involved with computers or developing software, you know at least one of the logos here. If you think about Oracle, a big company that starts with databases, they are relational databases. Most of the products, they have also one object-oriented. MySQL, open source, free available database that you can get and install in your computer. Similar with SQLite, Postgres, MariaDB. SQL Server is the commercial and kind of professional business version of the Access one for Microsoft. All of these products are relational databases. All of these products are the ones that you can use for your software. And by the way, if you look with Amazon, the AWS, there is also an option for relational databases. Most probably, they have more options here for the non-SQL, machine learning again, but relational, there it is also. Okay, step number one, we're going to create a piece of software. That piece of software is going to need a database. I can get one of these free. I can buy a license of one of these commercial and install in my computer if this is personal, install in a server in my company if this is for business, or I can buy space in one of these on the cloud. If I do not want to deal with the installation process and so on, this Some of these are available. The only thing that I need is the URL to connect. And once I am connected, I can send SQL instructions and I can receive or perform things there. Ask for data, I am going to receive the data back. Store data, I send the data, send the instruction, the data is going to be stored, whatever. I am free from handling the IT details here. Now, the only thing that I want you to remember now that we're going to move to SQL is tables, attributes, records, and the relationship. As I showed you before, they are also tables. These key ideas, 4 key ideas. We're going to create tables. They are going to have rows and columns, attributes and records. And the relationship between tables, like enrollment, is a relationship between a student and courses, is also going to be a table. Good. This is the idea. And this idea is going to move to an implementation. And we need to remember key concepts in the relational database. Key concepts. Primary key, foreign key. 2 key ideas in the relational model. Primary key, foreign key. What are you talking about? Well, I am talking about the following. Number 1, every single time that you create a table, rows and columns, in your tables, it's important to have a primary key. A primary key, a special column. A special column that we're going to call the key, the primary key of the table. In this case, ID is going to be the primary key of the student. The characteristic of that column is that all the values there are different. All the values there are different? Yeah, that is every single row have a different value here. This number here is different from the number of the following line and from the following and so on. Example, the primary key for you in the table student in ASU, your ASU ID, every single one of you have a different ASU ID, a different number. That number identifies you. The reason for that number is because we need a primary key in the table in which we are storing your information. The name, 2 people, 3 people or more can have the same name. Similar could happen with the last name. Similar could happen with several other data, your program, the state in which you were born, the date of birth. Several information can be duplicated. If I ask for the grades of a John Doe, maybe I have 2 or 3 or 4 John Does. But when I put a primary key column in a table, when I put a column and somehow I define a rule for that column to have unique values, like your ASU ID, automatically, this one is the key for that row. I can ask not for the information of Javier or John or whatever. I can ask for the information of a particular number, your ID. And that is the key for the row. Primary key, 1 column. 1 column in which all the values are different because that value identifies in a unique way the row. Similar with the courses. You can think that the ID of the course is CSI360 or CSI240. Those are just the titles, the names. There is a description that could be the full introduction to software engineering name. But in the database, we have a primary key for courses, a primary key that is usually a number. There is a number here. Do not need to start with 1. Like in the example, 101, 105 is just a number. But the rule is, and the database is going to take care of that. That number, 101, there is only 1 row with the 101 in the column ID. There is only 1 row with the 105 in the column ID, and so on. For enrollments, I talk here about the ID of the student. I talk here about the ID of the courses. Usually, you're going to have also another column that is going to be your primary key. Your primary key, this is just an example. For these kind of things, the transaction ID is like, I am your advisor and I do the enrollment of you in this particular class. This is you, this is the class, and automatically the database can generate a unique number for the ID, for the primary key. And that number is going to have a functionality later. That number is like your confirmation number. That is the number that you have every single time that you buy something, the transaction number, that primary key unique number that is associated with records in the table. That transaction ID 1, when you enroll in a class, is the confirmation that this student enrolled in this class. And the only thing that I have in this table is these two numbers. But with this number, that is the ID of the student, I can get all the information of the student. And with this number, that is the information of the class, I can get all the information of the class. So with this number, the confirmation one, I know who enrolled where and all the details. Primary keys, one column with a unique number. Second, another fancy name, foreign keys. Foreign keys. Here, every single table has this primary key, a number that is unique. And you know what? The values here and the values here. Do you remember that I mentioned that this ID is the ID of one student and this ID is the ID of one course? Something that we need to define, something that we're going to tell the computer is, computer, these two are going to be foreign keys. Foreign keys meaning that here in these spaces, the only value that you can put is one value that exists in the other tables. Think about this like having Excel, and instead of having the cell empty and being able to put any number there, the student 1 million or the class 99, what you're going to have is kind of a menu. And the only thing that you can do is to select one value from the menu. And the value is obviously one value that exists. Instead of having here an open space to put any ID for any student, the only thing that you can do, because we tell the computer that this column is a foreign key, foreign exists in another table. The only thing that I can put here is a number, the ID from one student that exists in this table of students. So I cannot enroll a student that had not been put here in any class. I cannot enroll in 360 a phantom, a ghost student. From this list, I can select a number. From this list, I can select a number. That functionality is called foreign keys. Foreign key. The value that I am going to use for a particular column exists in another table. Primary key. The value that I am going to put in a particular column is unique. Do not exist in any other row in this table. Two important concepts for the relational database. Primary and foreign keys. Everything else, columns and rows and tables. With those key ideas, it's like, okay, are you telling me that every single data in my bank account, in my agent view information as a student is stored in this way? Yeah, that is happening. For the designer, for the engineers, what I described to you looks like this. Yeah, you can be thinking, this is the relational model, and exists something called the relational diagram for databases. And yes, if you take a look, this looks like your class diagrams. Think about it. A class have attributes. A table have attributes, columns. From a class, you create objects. In a table, you store records. The records are going to be kind of the objects, particular values for the variables, the columns that you are defining. And there are connections from them. The students, classes, they are connected in order to be used in enrollment. And the important things, the only thing that we need to remember is the columns, and that some columns are special. These are all the columns. And here I am mentioning the primary key. You have 3 columns, and this one is a primary key. You have 3 columns, and these 2 are foreign keys. You have 3 columns, and one of them is a primary key. Use a graphical representation, but the graphical representation is useful to communication between humans, right? The important thing is we need to transform this to instructions for the database, to instructions in SQL to create this, and later to add, remove, or update data in these tables. So from here, we can move forward with the language. We need to talk about SQL. SQL. 2 things that we're going to do and 2 fancy names to remember. Number 1, SQL is going to help you to create what? The tables. And the tables with the columns, the attributes. And the columns, including those that are going to be primary keys or foreign keys. All these concepts, somehow I need to share with the computer when I am creating my spreadsheets. There is one part of SQL, structured query language, that is going to help you to create the tables and to specify foreign keys and primary keys, and obviously to specify how many columns the table is going to have. That part of the language have a particular name. Data definition language. If this is the language, SQL, I need you to think about 2 parts. The instructions in the language, or the words, the sentence in the language that help you to create the tables, and the instructions in the language that is going to help you to work with the data, the records, the rows. What can I do with the rows? Insert a new row, update a row, or search for a row, and search is going to be a special word, maybe the one that is most used. Select, update, insert. Delete. All this manipulation of the data. Insert, update, delete, search. All the previous one, definition of the structure that I am going to use to work with the data. You can think about object-oriented, and on the one hand, you have the definition of your classes, and in the other hand, you have the definition, the creation of objects. But here, with data, create a spreadsheet, working with the spreadsheet. And SQL, the language, is going to help you to do both. Okay, good. Step number 1, TDL, creation of the table. That is the point in which we need to start. That is the first thing that we need to do. Definition of the database that we want to use. For that one, this is the diagram that I showed you before. These are the instructions in SQL to create that structure of tables. And I am going to use your help to figure out things. This is a language, like a programming language. So you can notice that we have instructions. But beside the instructions, there is a syntactical rules that we need to follow. Just like when you learn Java and how to create classes and how to create methods, what you learn is keywords and syntaxes. Keywords and syntaxes for SQL DDL. The most important instruction, create table. Let me be clear, is one instruction, 2 words, one instruction. I want to create a table, and we already know what is a table. Second, I am sure that you can imagine the syntaxes. Create a table, space, the name that you want for the table. We're going to need to identify the table later. They are going to have a name, just like your classes. Do you remember class, the name of the class, open curly bracket, SQL, create table, the name of the table, open parentheses. Okay, looks good. DDL, data definition language. Yes, language again, language again. SQL, the full language. DDL, the definition language, the subset of SQL for data definition, well, definition of the tables. And the semicolon is back as a delimiter, just like if this were a class in C++. And inside of your classes, you have your attributes. Well, we have attributes here with the tables also. The attributes represent the columns. The attributes, they have a name, and they have a data type. A data type for the columns in a spreadsheet. Yeah, think about it. You use Excel and you can select one column and you can put a format for that column. And that column could be numbers or text or dates. In Excel, it's just the format. But thinking about the computer, well, the match is that column have a particular data type. The data type defines what kind of information you can store in that column. So for instance, in all the examples that I showed you before, the student ID is an integer. Integer, uppercase, yeah. Last name and first name, strings. The name for the strings in the database model. We're going to have options, I am going to show you, but is text, is characters, an array of characters, and in particular, bar chart, variable size characters. A string of characters with variable size. Starting with 10 characters, it can be less. My table student with the columns ID, last name, first name, 3 columns. The ID is integer, the others are strings. And I need to define one primary key. And in order to define a primary key, there is an instruction. And it goes inside of the definition of the table, primary key. And inside of parentheses, which is going to be the primary key? In this case, student ID. Again, 3 columns, and the definition that one of them is primary key. One of them, the values inside of that column, every single row is going to have a different value. Remember, that is the primary key. This column, every single value, the value for each row is different to the others. Is every row unique, like your ASU ID. Similar with classes, courses. The ID, one column, the title, another column, the description, another column, a little bit bigger than the other, instead of 10, 100 characters, and a primary key. The columns, the keys. Maybe the most interesting, the last one, enrollment. Enrollment. In enrollment, I want the transaction ID, the enrollment ID. I am going to need a column student ID in which I am going to store the ID of one student. Class ID, just like in my example before, transaction ID, the student, the class. But I want to define primary key. You know what? This enrollment ID is a primary key. What is the idea? Whatever value in that column should be unique. I cannot have two enrollments ID the same because it's kind of the number that is the proof that some kind of enrollment happened, right? Transaction. Primary. But also, and this is the most important, is like, wait, the student ID and the class ID, those columns are going to have data, but the data that you put there should be data that already exists in the table student or in the table courses. I cannot put any value there. The values there should be something like I mentioned before, like if you have a menu and the only thing that you can do is to select a value from the menu, but you cannot put something new. In SQL, that restriction, that constraint is expressed in the following way. You know what? It's going to be a foreign key. That is the instruction, 2 words, foreign key. The foreign key is going to be this class ID. Class ID is this column here. I am talking about my own columns. Table, this column here, the columns that have the name class ID. That one is going to have values only, references only, that exist in this table here. Did you notice? The name of another table, the connection with the other table, in this particular column. Any value that you put in the column here should be a value that already exists according with this definition in this table, in the column that have the same name. That is the validation. Who is going to do the validation? The database system, not you. If you try to put here a value that do not correspond with this rule, the system is going to tell you this is an error. You cannot do that. The system is going to be checking that this and this happen in order to create a new row in this table. So, obviously, I cannot teach you a new language in 1 hour, but hopefully you read this and it's clear the instruction to create the tables, how to create the columns, name and data type, and moreover, how to define the restriction for primary key and foreign key. Inside of the same instruction table, primary key, foreign key. For the primary key, the only thing that you need to do is to tell the computer which is the name of the column that is going to be the primary key. For the foreign key, you need the name of the column and also a reference. A reference is the data in this column is going to be in which table, which column. This column is a column in this table. This column is a column in this table. And the connection is the one represented with this line, creating tables, defining columns, primary and foreign keys. Good. I didn't put that in the diagram, so you will notice the difference with the names and also here. I didn't put the other rectangle with the primary. Don't worry. Good. So, data types. I am sure that you're thinking, well, if this is a language and we have data types, which are the data types that are available? We're not going to review all of them, but just for you to know, there are integers, there are booleans, obviously floating point numbers, float, double, real. I explained the difference there. Varchar is the most common one for strings. However, you have others. You can think about the difference here, something like a vector and an array, fixed the size or variable the size, date and time. And maybe one that is important to mention is blob. Blob helps you to store binary data in a table. Blob is the data type for a cell that can store, for instance, a picture, a binary file, such as an image. You can create a table, and one of the columns can be data type blob. And therefore, you can store something like the picture of the student in the same table in which you have the name and other things. Honestly, is not exactly a good idea because the size, because the difficulty of handling this in the systems. Usually when you have data like binary data, for instance, the pictures, they are not in the table. They are what you store is a reference to the picture, a URL to the picture, and the picture itself is in a different part of the system, in a folder maybe. However, it is possible to store binary data in one space in a table in the relational model. The data type, blob. Another note here, all these data types and also the syntaxes that I am showing you is going to be the core the same. For instance, create table, for instance, primary key. Those key things are going to be the same in any flavor of SQL, but in some instances, the data types are going to be different. And in some instances, also the syntax of the SQL is going to change a little bit. For instance, instead of having this primary key at the end, in some flavors, this should be here. So in the same row, in the same line, the name of the column, the data type, and whether or not it's a primary key. Small changes. The point is, even though you have a core SQL, you have a lot of systems that implement not only the database, but some of them, their own flavor of SQL. Think about this. You know English, but in different countries, even though the language can be English, there are small changes, small things that are a little bit different from the other country. Something like that with the database systems. MySQL is almost the same with the small changes from the SQL that maybe you are using with Postgres or with Oracle. When working with SQL, usually always is a good idea to take a look to the manual and check the small differences in the data types, in the syntaxes, and so on. So these examples work with MySQL. I am using the version of MySQL. When you move this to a different system, probably you are going to notice instead of integer, int, you are going to notice the change with the primary key, among others. Don't worry, that happened with this language in particular. Maybe similar to what happened with the several versions of C, C++, is something that do not happen with Java, right? Anyway, so creation of the tables. Now, also additional, if you already create a table, sometimes you want to update your table. Sometimes you maybe want to add a column to the table. I forgot to add the column DOB for a student. The instructions to change something in a table. Alter table. Create table to create a table. Alter table to change something. Now, change something. Where? Name of the table. What do you want to change? I want to add something. Well, I want to delete something. Delete, drop. Or I want to rename something. Alter table, student. Add that column. If you are going to add something, you need to give me two informations. Number one, the name of the column. Number two, the data type for that column. Remember, those are the two values that you need. So the values, add the instruction in this table. If you want to delete something, the only thing that you need to tell me is the name of the column that you want to delete. You do not need to specify the data type, right? The column in this table, this column, delete all of them. And obviously, like in Excel, if you delete the column, all the data in that column for all the records is gone. Rename the column. You have, well, in this case, rename the table. You have alter table, classes, rename. I do not want the name classes for the table. I want the name courses. So rename the table. And obviously, another thing is, well, you know what? delete, drop the full table and run. And yeah, we need to be careful because if you do a drop table enrollment in the production system in ASU, goodbye to all the information inside of that table. It's like delete a spreadsheet in Excel, right? All the information gone. Data definition languages. Create, alter, drop tables, because the only thing that we have is table. What happened with the records? Well, moving forward with the records. With the records, what we use is the data manipulation language. Again, we're talking about SQL. SQL is the language, but for some reason, these people separate the language into parts, DDL, DML. It's the same language, two subcategories. Fine. The data manipulation language is the part of SQL that is going to allow you to work with the records. The instructions for that, as a quick summary, as I mentioned before, you have an instruction insert, you have an instruction update, you have an instruction delete. Notice, drop was for the table. Here, delete is going to be used to work with the rows. And select. Select, maybe the most important one. Most of the things that we do with the data is to retrieve data, search the data, get access to the data. Insert, update, delete are operations that happen a small number of times. The select is probably the most important instruction that you are going to learn or that you need to learn if you're going to work with this. Anyway, reviewing them, the syntaxes. In blue, uppercase, I am sharing with you the keywords. All the other things are kind of the syntactical rule. What do you need to put after each of the words in order to make this function? Let's move forward. And again, this is like a program. The first thing that I did was to create my tables. Do you remember in the picture, I put numbers 1 to 23. That should happen first, creating the tables. Second, after creating the tables, lines 24 to 39, I have my tables. I want to put information inside. In order to put information inside of those tables, what I do is not go and visually modify the tables. That do not exist. That is Excel. In the database, what I do is talk with the system using the SQL language. And I ask for, you know what? Insert. Insert what? Insert into. The complete instructions. Insert into. The name of the table, insert into this table, the table classes. And here I have two options. Option number one, if I am going to insert all the values for all the cells in that row, the only thing that I do is insert into the spreadsheet, the table classes, values, this is a keyword. And I put inside of parentheses all the values. And as you can expect, if they are numeric, use the number. If they are string, quotation marks. So for this example, classes, the table have 3 columns, the ID, the title, that was varchar, and the description, that was also varchar. I want to insert that. Now, if for any reason, I do not want to put values in all the columns, insert into classes, and I can put here, after the name of the class, the columns that I am going to use. In this case, for instance, I am going to insert into the table classes, but only I am going to use the column class ID and the column title. I do not want to use the other one, the description one. And then values, and it's okay if I provide only 2 values. 2 values because I mentioned the name of the columns. If I do not mention the name of the columns, I need to provide all the values for all the columns. Makes sense, right? Now, notice that here I put a 1 and here I put a 2. That one, the first column, the class ID, is the one that we define as a primary key. That one should have always a different value for every single row. So the number 1, the number 2, and when I continue, I can use the 3 or the 23 or the 100. It doesn't matter which is the value, but should be different from the one that I already have. the ID. Similar idea, if we think about the students, insert into students. I am creating 3 students. I am telling the computer 3 new students. Primary keys, like your age, UID, all different. The name and the last name. Enrollments, insert into. Enrollments, I am going to use all the columns. Values. Primary key, all of them different. 1, 2, 3, 4. And again, you can continue. You can use the 5 or go directly to 16, 20, whatever. All the values different. Student and class. In the same order that I define the columns in my tables. What I have here is 2 courses, 3 students, 4 enrollments. That is my data. Now, with that data, I can play and do updates. It's another instruction. Update the table classes. It's like go to the spreadsheet classes and set keyword. Set, what are you going to do? What are you going to change? The description is going to be equal to programming languages. Okay, you want to update the table classes. You want to put the value programming languages in the column description. If I put here a semicolon, if I make the line 36 the instruction for the computer and I press enter, hopefully you agree with me that in any place in that instruction, I tell the computer in which row I want that. I am telling the computer I want that, programming languages, and the value for the column description. Column description, this value. If I press enter there, the computer is going to put that in all the rows. All the rows, the description for all the rows in classes. So the description for the class CSE360 is going to be programming languages. And the description for 110 is going to be programming languages. All of them are going to be done. Obviously, usually, you do not want to do that, right? Usually, you want to put that in one column for a particular row. So this space here. An instruction that is going to be common in several others is this where. Where is the one that helps us in SQL to localize a particular row. So the instruction here, the semicolon is here. This is my instruction. Yes, you can use 2, 3, or 4 lines for the same instruction. The instruction didn't finish until you put the semicolon. So in this case, my instruction is update the name of the table, set the value for the column, where the condition. The condition, title equal CS240. Think about it. You have a table, and what is going to happen is, okay, this is the column description. I am going to put programming languages. Wait, I am going to search in the column title, the row that have CS240, and in this row, in this column here, I am going to do the update of the description to programming languages, one particular place. Obviously, if there are more lines that have that title, 2 titles, 240, both are going to be updated here, but not the full column. Set what to change, where, which row to change, update for the data. Obviously, similar idea, we have the instruction delete. Remember, delete rows, delete records, delete from, into 4. Delete 4 from students. I want to delete something from the table students. If I only put semicolon, that is the instruction for delete everything in the table. Goodbye to all the records in the table. Clear the table. So usually you are going to notice a delete work with a where. Where? Well, the condition. Condition, student ID, the number 3. What is going to happen? I am going to search for the student ID number 3. And student ID is a primary key, is unique. There is only one row with the number 3 in the ID. What the instruction is going to do is to delete this row. That is what happens when you drop a course. When you go and ask for dropping a class in the system, in the software, in the database, it's going to be a delete. It's going to be an update. Delete, update, insert. These are the easy ones. The important one, select. Select, search for information. The hello world example for select, something like this. Select what? Asterisk. Asterisk is the symbol in SQL, like in other places in your computer, to say anything. I don't care. Give me all the information that you have. In that place, represent name of columns. Give me all the columns. I have no idea how many columns there are, but give me everything. Select asterisk from the table. Which one? Student. Give me all the columns from the table student. The result that you're going to get is going to be something like this. The computer is going to give you the header, obviously, the name of the columns. I have 3 columns, and it's going to give you the value for all the rows. Select asterisk from students. Select asterisk from courses. Select asterisk from enrollment. Get all the data. Moving forward, we can do things a little bit more elaborated, more complicated. It's like, well, wait, select. And here I am going to use more than one row, but again, the instruction finish until you put the semicolon. So select. Select what? I do not want everything. The only thing that I want is to know the last name and the first name. So I only want those 2 columns. Your result is going to have only 2 columns. From where? Still from students. I am going to work with these spreadsheet students. You want all again? I mean, you want, I only have 2, but you want everything? No, you know what? I only want 1 row or a few rows. The where again, and the condition. Student ID equal 1. I am asking for the name and the last name of the student, which ASU ID is the 1. And that is exactly what I am going to get. This is what happens when you go to the office of your advisor, and the first thing that your advisor asks you is your card or your ASU ID. If you borrow your card, the only thing that happens when you scan the card is we get the number. And we need the number because with that number, we can do a select like this in the database, and therefore we can get the information that we have from you. Not only your names and last name, but enrollment and other things. A select, because we have a relational database. You notice we're using select for the columns, we're using from for the tables, and the where is optional, but with the where you can create conditions. And yes, you can have more than 1 condition. Like in Java and other programming languages, we have the and the or. In Java you use these guys. In SQL, and use like that, and. In Java you use these guys. Here we have or. Use the word like that. Moreover, condition and or, another condition, and or, another condition, you can continue. Operators, I show you examples with this equal here, but as you can imagine, you can use the equal, different, greater than, lower than, and so on. The relational operators are available. Moreover, you have available this
between, like student ID between 1 and 5. So it's going to give me all the students that have this ID between 1 and 5, something like that. The opposite, not between, inside of a particular collection, not inside of the particular collection. There are particular instructions, not all of them available in all the flavors of SQL, but one way or another, these are functionalities that you're going to have in order to work with a relational database. So with this, you can create complex conditions for searching data, for using the data that you have. Also, the equal that I showed you, the different one, but not only you can use different or equal, there is also something like. And for the like, you can say, you know what? I would like to have all the information from a particular student, and is only one, so I am going to use a where. And I kind of remember that the first name was something like, instead of equal, have something, and the symbol for the something. So the name starts with those letters and something else that I cannot remember, but database, please help me to search. Is I am looking for a student, that the student have a name, and the name is something, whatever. Or the last name is something with G-O and something else. Or even you can put something like percentage something at the beginning, something at the end. I do not remember the beginning, I do not remember the end, but in the middle, the letters are something like this, or the number is something like this, or the record is something like this. Like the opposite, the character to represent those things, and so on. Details. With this SQL can work. I want the ID, the last name from students, last name, as I mentioned with the first one, but this with the last one, G-O-N. And this is what you are going to get from the computer. Select. Bigger one, more complicated one, and this is just an extra thing, but you can do the select not only from one table, but from a combination of tables. This is obviously the most useful thing. This is the big difference between using Excel and using a database system, because so far everything looks like, oh, Excel. I can do a select, and the select can be from not only student or courses, but from student, courses, and classes. I want to do a select, I want to do a search for information, and that information is somehow in those three tables. Give me the information from these three tables in which, you know what? The student ID in enrollment match a student ID in student, and the class ID in enrollment match the class ID in classes. When you run this, you're going to get these columns that are not in enrollment, even though you are using enrollment to make some kind of comparisons. With this SQL, with this select, what I am doing is show me the data that you have in enrollment, but do not show me those crazy numbers. What I want is the name of the people, and what I want is the name of the classes. What I want is to show this to my user, and my user do not know or remember the IDs. So looking to the enrollment table and checking this 1, 1, 1, 2, 2, 3, 4 is not useful. What I want with a particular select is, you know what? Jane Doe is taking 360, Jane Doe is also taking 240, and Javier Gonzalez is taking 360 and 240. One select, 3 tables, get the information. Obviously, I am not going to ask you for things like this. This is like, here, you can continue exploring SQL. But at least the simple things, the ones that we reviewed before, I need you to be familiar with this, check these examples. Your homework this week is going to be use this, practice with this, see what happened with this. I am going to share with you some SQL instructions, and I am going to share with you access to a database, well, quotation marks, a database. You're going to have the opportunity to play with SQL at least. Any question? Okay, guys, so we finish here. Next week, I am going to post the video with the review. It's not going to be live with you because the Thanksgiving. And in 2 weeks, your final exam, as usual. You need the lockdown browser, and I am going to be posting announcements about it. And that's it. Thank you.